Hello, my name is Debansh Darnde and I'm currently pursuing Masters in Data Science and Artificial Intelligence. For my dissertation, the topic of my project was to predict question difficulty using large language models and knowledge graphs. So with that context, let me take you through the slides and show you what I have built.
As discussed earlier, the topic of my presentation is predicting question difficulty using large language models and knowledge graphs. And as we progress, I'll make things more clear about what exactly it is and why have you used LLMs and KGs for this project. So let's dive into the first question of it. Why have we used KGs and LLMs for predicting question difficulty? The reason is we have to match difficulty to learner competency because we have to ensure questions are appropriately challenging for which improves learning outcomes and assessment accuracy. Also, if we go on to label the questions manually according to easy, hard, medium, difficult, it lacks scalability and it is not uniform. And that's why we aim to create a uniform system for the same thing. The key technology we have used are knowledge graphs to extract the information and keep it organized. We have also used large language models to actually predict the difficulty of the question. We have used a Streamlit web app. That way, we have an end-to-end pipeline to upload the knowledge graphs and create questions out of it and label them instantaneously. We have integrated the entire workflow and the model which we are used to generate the responses are also available offline, and hence all the processing are done offline for speed and privacy. So let me quickly go over the pipeline of my project. We will first start with a knowledge graph or ontology, and then we'll generate questions out of it. And there can be a rule-based question or LLM-based questions. And then pass these generated question to difficulty prediction module, which are again powered by LLM. We have engineered some prompt around our offline LLM to get consistent results every time for the difficulty of the question. Then we can compare the predicted difficulty against the ground truth or human annotations, which are basically human inputs towards it, and we can verify if our model is working as good as it's supposed to be. And then we can obviously integrate the entire system into an end-to-end pipeline for intuitive use case using Streamlit, and we can have we have developed a web app for the same. The experimental setup is as shown. The data set here, which we have is a ontology which is driven from public available knowledge graphs. The model is Mistral 7B. I have implemented it using Olama and I have downloaded the entire model for faster search and privacy. The interface is done using Streamlit and it looks like this, which I'll be showing it in the demo. And the evaluation is done based on human annotated difficulty ratings, which I have personally rated and compared with the outcome of the generated questions based by LLMs. So let me go over the demo of this. So for the demo of the project, I'll just go full screen. This is how the project looks like. It is divided into these many versions of the app which I've made. These are all the helper functions which I've experimented independently. Each utility like difficulty prediction or enhanced text using LLMs or OWL parser or question generator have been tested independently, and then I have integrated it to the final version of my app. These versions of the app are constant enhancements over the weeks of the project duration, and app V8 is the final version which I've settled for this. So this is how the project looks like from now. I will go over the details after I've shown the demo. So I'm using Streamlit to deploy the app uh, on a web interface, and it looks like this once I have it here. So this is the interface. So basically, if I upload an OWL file, it should be able to generate some LLM generated questions and some rule-based questions. So let me just pass on a OWL file to it. So once I pass on the OWL file, it passes to the OWL file and generates this knowledge graph. This knowledge graph is basically graph of solar system. So you can see like Shoemaker Levi is a type of comet, and it has all these nodes like who discovered it, uh, what is its density when it was discovered, And it has information like that for every entity. Like this is Venus, and we can see its orbital radius and mass and everything. So this are all the information which we could get from it, and these are the triples which I have generated. So basically, this graph will have triples like that, which is like subject, predicate, and object. So gas giant is the subject, predicate is the disjoint with, and terrestrial planet. We can see that there are some garbage triples also in this, which makes no sense. Like this has no meaning for the question. So we had to filter all those things because not every knowledge graph is perfect for it, but we have some valuable insight like Venus has orbital radius. So we can create some questions based on that. So we had to filter it out, and these are the triples. And then this is the LLM question generator. It just passes on the triples to LLM and generates the question. It takes a little bit of time for the parsing. And once we have the questions ready, we can see it. So these are all the rule-based questions, and it says how many rings does Saturn have. It is classified as very easy. When was Intermania discovered? It was classified as very easy. What is the orbital period of Intermania? So basically, we might have to go to multiple jumps to do this. So this is being classified as a medium. So yeah, this is the final rule-based question generator. We also have made LLM-based question generator. It takes the triples and it tries to, because these are all very simple questions. So based on the rules, so we have to hard code every type of question in this. But here we just take the triples and we try to generate questions out of it. The the benefit of this is it can generate some complex question, like these are all new question every time. Is Miranda one of the satellites that orbit around a planet in our solar system? So we have to check what all the planets are in our solar system, and then for every planet we have to check if it is a moon. And what is the data type typically represented by the mass value of an astronomical object? Sometimes the LLMs might not give a very coherent question. So this is one a limitation with the LLM-based question. It does not have the context of the graph, so it might not be able to give very good quality questions. Whereas the rule-based question will be on point, but we have some entities which makes little sense, like Earth atmosphere is one entity, so we have to focus on that also. It might not always be coherent using the rule-based question. So let me just show what is there. The final version of the project comprises of difficulty estimator. It is basically we have given this prompt to our offline model, which had multiple shot prompting. I experimented one shot prompting and few shot prompting, and I realized that with multiple shot prompting, get we can actually explain the requirement that we how we have to rate each question. Very easy will be a simple factor definition. Easy will be one-step reasoning. Medium will require multi-step. And then we can give some positive example to show what kind of result we want. And then I realized that if we just add negative example, it just makes the uh, predictions better. After that, we just build the prompt on top of that. I just call the Mistral Olama model, and it just takes in the prompt and predicts the difficulty. This is the display knowledge graph. I used net model for net library for that. These are the rule-based question. If it has atmosphere, then we can just ask. So basically, it gives rules to for the knowledge graph, and it makes questions based on that. And these are the LLM-based question. This is the prompt I have used to give them. So basically, I've paused the subject, predicate, and object triple, and given this prompt so that we can generate some question. This is just to get the difficulty tag, easy, medium, difficult, and this is the main function which wraps up everything. Some honorable mentions from this were the V3 and V4. So I have already run those things. So this is the V4 version. Let me just show it to you how uh, the V4 version is basically earlier I experimented with the DBpedia approach. So basically I tried to extract the graph from DBpedia instead of just relying on uh, the instead of just giving the graph. So I realized that DBpedia has a very messy interface, and this is the kind of graph we get from DBpedia. It is a public library for getting the graphs, and these are the extracted triples out of it. And I realized a lot of things are not good enough for generating questions. And the questions which are generated were not very high quality from this. So I had to move on. The V3 version I earlier used was, let me just show you the V3 version before DBpedia. So V3 version basically takes in some paragraph. So I can just give this paragraph, and I will be using LLM for triple extraction. So basically I will pass this paragraph to LLM and ask it to generate some triples so that I can make a knowledge graph. And then also I wanted to enhance the paragraph before extraction because there are some things which might not be understood well by the LLM. So I take in this paragraph and enhance it to make it very suitable for triple generation. So since this is a very heavy LLM usage, this takes time. I have a cached version of this where I have run this before. So basically, I take this paragraph, I process it like this to make it simple with subject, object, and predicate. And based on that, the LLM extracts these many triples, and I can get this knowledge graph. And once I have the knowledge graph, I can actually generate question. When was Albert Einstein born? When did he graduate? So this was the knowledge question generation pipeline which was used earlier, and we have updated on it, and we have finally settled with this for our final project because this gives more uh, in-depth questions, and hence we have settled with that. So yeah, this is how the project looks like. There are some other things which I have tried, but I'm running short on time, so I will not be able to go over that. So yeah, thank you. We can move ahead with the uh, results. So this was the result. I have the questions given to the model, and human difficulty was I have rated the question, and the LLM predicted. And we can see that only the medium part of the questions were hard to categorize because easy and medium are not very difficult to separate. After that, the challenges which I face is the some unrealistic questions generated from LLMs, so they don't have context. So we have to make some post filter. DBpedia, as I've shown in the V3 portion of the graph, it was very messy and it did not give very valid results. LLM does not have domain specific fine tuning, so we had to work around that. And mid-level questions are very difficult to calibrate. It is difficult to suggest for a human also, but but LLMs are able to give it in a range with some margin of error. Future work, we can actually curate domain-specific ontology, improve calibration with human annotation, and add confidence scores on this. And we can have it very well for question generator plus difficulty estimator. Thank you. It was under the guidance of Dr. Terry Penn, who has been really helpful. This was on project. I hope you liked it. Thank you so much.